Hello students. Hello students. Java programming course. Unit 3, Chapter 2, Inheritance in Java. And we know that this second chapter, Inheritance, is composed of 4 videos. In 4 videos. Video 6, Video 7, Video 8, Video 9. And this is the last video of this Inheritance chapter in Unit 3. And these are the topics we are going to discuss today. Using final with inheritance, final keyword, and access control in the inheritance, and object class. This object class considered as universal superclass. First one, using final with inheritance, final keyword with inheritance topic. So here, using final with inheritance, the keyword final has 3 uses. 3 uses. The first one is it can be used to create the equivalent of a name constant. Then this final can be used to declare any instance variable of a class, nothing but a variable, as a final, and it the named constant, considered as named constant. And the other 2 uses of final apply to inheritance, right? So that it is how this final keyword can be used to used in inheritances. Using final, we can prevent overriding, method overriding. Got it? And disallow a method from being overridden. Specify final as a modifier at the start of its declaration. Then we can prevent the method overriding in inheritance and creating class hierarchies. And methods declared as final cannot be overridden. So using this final keyword, whenever we use this final keyword in any class of class hierarchy, then we use this final keyword precedes the function or method definition in any class. That method cannot be overridden in the subclasses. Then coming to example program here, using final with inheritance. So here in class A, I have a method called meth, and the type of this method is void. And in the definition of this one method here, a final keyword precedes this function definition, final keyword. Then this method becomes a final method defined in class A. Got it? So finally, inside this method, a displaying statement using the system.out.println, this is a final method. And this statement here, class B extends the properties of existing class A. Now here class A is a superclass and class B becomes a subclass of this superclass A. And here this subclass is going to override the method defined in the superclass met with type void. The same function name of this class subclass is going to override. So here this compiler gives an error about cannot override the final method in the superclass. So right, we'll see this part of implementation in the execution part and let it conform in the execution part of a program. So here, coming to the program, we're saying in the PPT here, class A is a superclass having final method met, and it displaying this is a final method. And whereas class B extending properties of existing class A, and trying to override the method defined in the superclass name with name method. So it gives, we are trying to give the to do this one in the subclass overriding the superclass method. This compiler gives an error, and we'll see this part in the execution. So what is the name we have taken for that class? Final, FIN. So no errors. Here it is. If you observe here, it given an error in B cannot override method in A because the overridden method is a final. So this is the statement given as an error while trying to execute this program and JVM. Okay, now I'm trying to delete this one. I'm going to execute. Then inside of main function or main class, I'm just creating an object of A and calling that method function defined in the superclass. As it displays simply this is a final method. We will go and see this in the execution part. See here. Again, I'm compiling and executing as it is called the superclass method. Got it? When we are defining a method here, so it simply gives this part, it gives an error. Okay. Okay, understood. What is the concept here? Whenever the method is declared as a final, it cannot be overridden in subclasses, right? If you attempt to do so, a compile error will result. Got it? Here, this is the one of the concept with this final using with inheritance. Next one, methods declared as final can sometimes provide a performance enhancement. So this is one point to be important to remember. Methods declared as final and how this concept is related to enhancement of the performance of a system execution, right? The compiler is free to inline calls to them because it knows they will not be overridden by a subclass. So whenever a method defined as a final in the superclass, then the compiler is know that concept that they will not be overridden by a subclass. So whatever the final methods defined in the upper class, superclass, something superclasses, and all those functions will be considered as inline functions while executing. So in inlining is an option only with final methods. Normally Java resolves calls to methods dynamically at runtime. Usually the process like this. In Java, most of the method invocation or method calling resolves at dynamically or resolves at runtime only. And those method calling resolves dynamically and at runtime. But here, and this is called late binding. And generally inlining an option only with final methods defined in any classes, and the compiler free to inline those calls of the methods because, and you know the concept of inline, when the method is going to call in main classes, the compiler generally do at compile time is it places the code of at the time of compilation. When we make a call to a method defined as a final, then at the time of that function call, it replaces the function method code completely at the compile time for executing past those processes, right? So this is called a late binding. Late binding generally late binding is a dynamical binding, and however, these since final methods cannot be overridden, a call to one can resolve at compile time. This is called early binding. That it means here you can able to understand the concept of this inline methods of a class. Generally, small functions, only the small type of function, the functions who the methods of small size, and we define those functions as inline. And the use of this inline function is whenever we invoke this function of type inline type functions at compile time, generally a function call replaces uh, this function call with the reference of the method where it's stored in the memory. That is the actual concept done at compile time. But whenever the method is of type inline method, a function call compiler replaces not the reference of method stored in the memory, it replaces that function call at compile time by entire code defined for the method and at the time of function call, in the function call at the time of compilation. So while doing this type of process, then automatically we can improve the performance of the execution of the program. So this in Java specifically with this methods declaring as a final, and those methods are treated and convert that as an inline functions at compile time. So, but usually in Java, calls to methods resolve at runtime that considered as a late binding, but Java making these final methods as a inline methods and replacing the method code at the in the place of function method calling. So it can be resolved at compile time. That it means early binding, not at runtime. Got it? This is the one of the use of this final methods declared in any class, and it improves the performance of a execution of the programs usually in Java language. Next one is using final to prevent inheritance. So this is also the concept. How these inheritance is we achieving in the Java programs in the concept called inheritance. What this inheritance means, creating class hierarchy, and we are providing relations among the classes by extending the properties of one existing class to new derived classes. So here, when we declare any class as a final, so it automatically prevents inheritance and creating class hierarchy. So sometimes you will want to prevent a class from being inherited. So to do this, precedes the class declaration with final. So it is simple as like you define method as a final. So when you are declaring a class like class A and use the final keyword that precedes this class declaration, final class A, and this is class body language. So whenever declare any class as a final, and any class, for example, class B, trying to extend existing class A, so this is not a valid declaration of subclasses. Compiler gives error here because this final class cannot be inherited. Got it? Declaring a class as final implicitly declares all of its methods as final too. So when we are declaring a class as a final, that it means implicitly or automatically need to define every method defined in that final class as final too. Okay. Next one. It is illegal to declare a class as both abstract and final. So it is not allowed in Java. You want to declare abstract class, yes, it is having some rules and regulations to declare any class as an abstract. You just go and follow those. And we're having some guidelines to declare a class as a final and declare that class as a final using those concepts. But don't combine these two keywords to declare any class, right? Since an abstract class is incomplete by itself, and relies upon its subclasses. Why? Because this abstract classes gives only the methods of in a general form, and subclasses they implement those methods overriding by implementing their own, and to provide complete implementation in the subclasses. Got it? See that one example of this final class. So class A is declared as a final, and inheritance or by any subclass B extending A, it cannot be allowed in inheritance. Why? Because the class A is a final class. If any existing class declared as a final and those classes are not inherited in any cost, right? As the comment implies, it is illegal for class B to inherit A since A is declared as a final. So that's why inheritance is not allowed for that class, right? We'll see simply in the execution part here. We try to see the same with the previous class. So here I'm declaring class A as a final, right? As a final. Then I'm going to do this one. Okay, saved. And I'm trying to go to execute this one. Yes, same Java C thing. So here it gives another. So because class B doesn't allow to inherit class A because cannot inherit from final A because A class A is a final class and we declare that class A as a final class and no other classes are allowed to inherit that class. Got it? Understood? Next one. The next topic is access control and inheritance. And we know that access control is already covered in many many topics of in Java language. And we see everywhere in classes and object concept or chapter also we discussed about this access control. And now it's time to discuss about this access control system for this inheritance concept. And we will discuss the same access control in the next chapter packages also. So here a derived class that it means derived class means subclass access to the members of superclass may be modified by any access specifier defined there. So there are three access specifiers and we know that public, protected and private. So here the code for specifying access is access specifier or access modifier followed by type of the member identifier, type of the member going to define in the class and member identifier or name of a member. Either it may be instance variable or maybe any method defined in the class. For example, we can declare any instance variable like public space integer a. Integer a. Access specifier of this member is public and the type of the member is inheritance in integer and name of the identifier or member identifier is A. So got it? And you know clearly about this access controls very well. But in inheritance, in the previous topics, I'm going to remind you that where we discussed one point about this access control and inheritance, there is a special type of access modifier or access specification uh, available in Java that is in object-oriented programming that is protected. This protected keyword is specifically and meant for this inheritance. In inheritance, any superclass member defined as protected under protected, then those protected members of superclass can be accessed to subclasses that are inherited that superclass, right? And coming to here, these are the access specifiers. No access specifier means default specifier. Access permitted to any other class belonging to the same package And this packages concepts we discuss, and more about this access control we discuss there. And we will do some practical programs to better understanding of these access specification usages and when these power of these access specifiers will do, right? Public, anywhere you can access. Protected, access permitted to any subclass in any package, also to any class in the same package, right? So we will discuss this one in the example program also. And private, you know that only allowed in the same class, and no outside code has access to private member of the class. And we already covered this one in the clear. Next one, and access control about the permissions of the see here and packages here, and it's not right time to show about these packages, but just have this one. No access specifier means, so that is a default public, that it can be accessed by same class members, subclass members, any other class in the same package. So package is nothing but a some location where some classes, set of classes are available. So within that package, any class can access any class public members. That is the concept here. And we will see this one clearly in the next chapter also. And coming to when it is a public means at anywhere it can available. Any package, same package, outside package, different package, or same class, subclass in different package, wherever it is, it's accessible to anywhere in the program. And protected is only for subclasses and same class members, subclass in any package, any other class in same package, subclass in different package. So it relates only some inheritance point of view. This protected members can be accessed to some that context of view. Whereas private, this is only access to inside of the same class members, inside the same class, and you can any member in that same class can access this private members, right? Okay. Then coming to this access control and inheritance example program. So I have taken here one class A and one instance variable as public and one instance variable B as protected, for better understanding you how this protected member can be accessible to subclasses of this A. Here class B extends the properties of A. Now B is a subclass and it has instance variable C. But whereas coming to here, two methods defined. One is set method and one is display method. Set method is accessing all these instance variables of this superclass A and subclass B, and initializing these instance variables of superclass A equal to 10, B equal to 20, and instance variable of subclass C, local variable, that ends with 30. And display method simply displaying all these values on the screen. And coming to main class, so I have written this main function, so I forgotten, so don't mind. Inside this main method, I have declared one object of this subclass, and I'm trying to call those two methods, set method and display method. By executing this set method or invoking this set method by using the subclass object, so all these variables, public variable can access directly. Protected, as it is protected is a keyword introduced for this inheritance. When we declare any member as a protected, this can be allowed to access inside of this subclass group. Okay, got it. So it displays 10, 20, 30. We will go to this for in execution. So please remember here the same method here taken. The public instance variable protected B extends A, and set method initializing these values, display method displaying, and main class name is inherit. And inside main function, so I have just created an object and calling and invoking those two subclass methods set and display, right? Coming to the execution part and go to console. So see here, what is the class name here? Inherit. Yeah, Java C inherit.java. So no errors. Just you can execute this one, Java space inherit and 10, 20, 30. So that it is possible of this a b instance variable with values 10, 20. These are the two variables from superclass, and c variable with initialized with 30 instance variable of subclass. So all are accessible because this a variable a value is public and 20 is protected. Still it is accessible inside of subclass. Got it? Next one. So next topic is universal superclass object class. So this is also important to remember that there is one special class called object class defined by Java. All other classes are subclasses to object, subclasses of object. So whatever the class you create in your Java JVM environment, and there is a special class defined by Java, that is object class. Every class defined is a subclass to this object class. So that is, object is a superclass of all other classes we are defining in our programs. This means that a reference variable of type object can refer to any object of any classes. So we know that concept called superclass reference variable can refer to a object of subclasses. So that it means object class reference variable can refer to any object of any other classes we are creating in our programs usually. Also, since arrays are implemented as classes, and we know that arrays are implemented as classes in Java, there is a class called arrays, and a variable of type object can also refer to any array. So that is, any array you are creating with respect to that one, you can refer these objects of an array through the reference of that array class. Here also, object defines the following methods, which means that they are available in every object, right? So object class having some methods, and I will show you those in a table format. Here it is, these are the methods available in object class, and all these object class methods can automatically invoked by any class defined in your Java programs. And no need to create object of those classes here. You can call these methods by default in your programs, and you can call notify method, notify all, toString method, and wait method, and all these are for thread executions. And object clone creates a new object that is same as the object being cloned. So finalize method, hash code method, all these are the methods defined in object class, and we can invoke those methods into your Java classes usually without any attention, because all the classes we define in our programs are the subclasses to this object class created by the Java. Okay. Next one. The methods get class, notify, notify all, and wait are declared as final. You may override the other. And all these get class, notify, notify all, and wait. These methods are declared as final, and override overriding concept is not applicable to these methods. And remaining you can override, and you can override those methods, and you can implement on your own in your classes, as your classes are subclasses to this object class. Got it? However, notice two methods, equals and toString. Equal method compares two objects. It returns true if the objects are equal and false otherwise. Got it? This equals method defined by object class. And toString method returns a string that contains a description of the object on which it is called. When we call an object based on that particularly string related, then this function returns a string, and it contains the description of an object on what base you call this method, right? And also this method is automatically called when an object is output using println, right? Many classes override this method. And we know that toString method, and this can be used to automatically call when an object is output string connected to output string using this println. And many classes generally in the real time override this method toString for their purposes to return the string, with respect to the object it is called. Okay, these are the references, and thank you.